Okay.
So any questions about ratio and proportions? Okay. So percentages. We use percentages a lot. You see it in sales tax, right? Mortgage interest, when you buy your first car and you get that awesome high interest rate because you don't have good credit, because you don't have any credit because you're all young, right? Or if you have retirement and you're that age group, you have percentage return on your savings, right? We also use it in medication names like mag sulfate 50% solution, hydrocortisone 1% solution, or IV solution, we'll call it D5W, well actually that's the abbreviation. Commonly used and accepted, D5W means dextrose 5% water. Okay? So we use percentages a lot. Yesterday, I had a patient that had D5 with D5 half NS with 20K. Okay, so that's 5% solution of dextrose with 0.45% solution of sodium chloride or normal saline. Okay, those are commonly used abbreviations, and we'll do some math on the board that you'll see on your homework. Okay, so percentages refer to how many parts are related to the whole. Okay, in the whole, when it comes to a percentage, is always 100 parts. So a percent means of 100. So what's a cent? 1% of the dollar, right? Or you can just say 1 cent in short abbreviated term. Okay. So 5% would be 5 parts of 100, or 5/100ths in fraction form. But 5%, all that shows me is that I have taken away the 100 and just put a percent sign there. Okay. So I mentioned that IV solutions, we use percentages. Okay. But when it's used in IV solutions, we are talking about grams of solute in 100 mLs of diluent. So, here's the problem. You have 1,000 mLs of D5W in water. This will be one that you would see on your homework. So I have 1,000 mLs of D5W. How many grams of dextrose do I have in 1,000 mLs? So knowing this ratio and proportion, right, we talked about this. 5 grams, 5% is 5 grams in 100, and I have the other volume of 1,000, I can do the math. So 5 grams in 100 is equal to X grams in 1,000, right? Ratio and proportion, means and extremes, do the math. 100X equals 5 times 1,000, so X equals 50 grams. I will do a couple of these on the boards, so don't get too worked up or confused right with that, okay? The higher the percentage, the stronger the solution. So when we're talking about ratios and fractions, the higher ratio of 1 to 1,000 versus 1 to 10,000, the smaller number of 1 to 1,000 was the stronger solution, right? It's different when we're talking about percentages. Percentage, the higher percentage is the stronger solution. A little more straightforward, right? So a 10% solution is stronger than a 5% solution. There's actually there's D10W and there's D5W. So D10W is a stronger solution or has more dextrose in it than D5W, the 5% solution. Just remember, a 0.99 solution is going to be weaker than a 1% solution because 0.99 is less than 1. Okay. So percent symbols may be used with whole numbers, so like 15%, mixed numbers like 3 1/2%, fractions, 3/4%, or decimals, 0.6%. Most commonly you will see it though with decimals and whole numbers when it comes to percent. So if I want to make this a fraction, all I have to do is drop the percent sign and place the number over 100, right? So if I have 8%, I just drop this percent sign and put 8 over 100, okay? So 8/100ths is the same as 8%. For web study, we need to make sure that we reduce it. So we reduce that to 2 over 25. Okay. 1/4%, which I don't like fraction form for this reason right here. If I drop the percent, put it over 100, now I have 1/4 over 100, which makes a complex fraction, right? I didn't like those amounts written either. So, what you can do, you can make it 0.25%, which is the same, right? If I took 1 divided by 4, it would be 0.25%. That makes the math a lot easier. But, if I want to, I can take 1/4 divided by 100, which would mean that I would flip the second one, making it 1/4 times 1/100, get my 1/400, okay? So, make sure that try to use decimal places and whole numbers when it comes to percentages, and you'll see why here in just a second. If you want to change something to a decimal place, all you have to do is move the decimal, okay? So, all I have to do, if I have 25% and I want to change it to a decimal place, I just drop the decimal and drop the percent sign, and move the decimal place 2 places to the left. So 25%, get rid of that, move it to the left, 1, 2, making the answer 0.25. If I have 1.4%, get rid of my percent sign, move my decimal place to the left 2 places, 1, 2, and that makes it 0.014, okay, as an actual number. If I want to change a decimal to a fraction, then it's the opposite way, and we'll go over that in just a second. If I want to change percent to a fraction, or to a ratio, then I can just take my 10%, 10 over 100, reduce it to 1/10, and look, now we can make that fraction a ratio. Or you can have 10 to 100 and reduce. But reducing prior to placing it in this format is easier. So here we go, changing a decimal to a percentage. So if I want to change a decimal place that already exists, or decimal number that already exists, to a percentage, okay, then I move it to the right. So 0.45, the actual number, in percent form would be 45%, okay? 2.35, okay, moving to the right 2 places, 1, 2, would make 235%, okay? That's the easiest way to make a percentage, is just moving the decimal place to the right 2 places. Okay? So that's it. Let me show you some of what you might see on your homework. Okay. Move down. So you might see a question that says, you have 750 mLs of D5N S. How much dextrose? Grams. And how much sodium chloride? Okay? This is how you do it. Remember we talked about D5 being a 5% solution, 5% dextrose, right? So 5% dextrose would be equal to 5 grams in 100, right? Normal saline is 0.9%, right? So if this is 5 grams in 100, how many grams here in 100? Right? Using my percent method there. So 0.9% is equal to 0.9 grams in 100. 5% is equal to 5 grams in 100. Okay? So now I know part of that ratio. Here's the third part of the ratio, 750 ml. So let's solve for how much dextrose first. So I have 5 grams in 100 mLs equal to X grams in 750 mLs. X equals 5 times 750, right? What's 5 times 750?
3,750.
So I have 37.5 grams of dextrose. Okay, is that all I asked for? I asked for one other thing, right? Normal saline. Make sure you commit this to memory. Normal saline, unless it's specified half normal saline or quarter normal saline, the normal saline is always going to be 0.9% sodium chloride. Always. Unless it's specified otherwise specifically. So, like I mentioned, my patient yesterday was on D5 half normal saline. So what percentage saline were they on? 0.45%, right? Pediatric patients, we use quarter normal saline. So what percentage is quarter normal saline? 2.225. 0.225, right? Okay. So we know that we have 0.9 grams. We're doing the sodium chloride now in 100 mLs equal to X grams in 750 mLs. Do my means and extremes, right? So I have 100 X equals 0.9 times 750. Cross-feeding, Kelsey? 675. Divide by 100. Divide by 100. 6.75 grams sodium chloride. And that would be your answer. Okay, you'll see these. Once you start seeing these, they never go away. Okay, I'll start putting them here and there in assignments. Okay, so once they start showing up on assignments, you'll always probably have at least one of these on an assignment. Okay? Want to do another one? Let's do it. Mr. Hinch just said so. Dextrose. Dextrose? You mark my handwriting? No. I'm just kidding. Okay, so you have 850 mLs of D5 half normal saline. How much dextrose and how much normal saline, sodium chloride do you have in that solution? So what do we know right off the bat? D5 is equal to 5%, right? So that is equal to 5 grams in 100 mLs. We have half normal saline. So normal saline was 0.9. So half of that would be 0.45%, right? many grams in 100? 0.45, right? You guys see that relationship? That all I'm doing is taking off the percent sign and putting grams in mLs, 100 mLs for both of them. 0.545%, took off the percent sign, put grams in 100 mLs. Do you see that relationship when it comes to IV solutions? Percentages, okay? So let's get busy with the math. Dextrose, 5 grams to 100 mLs is equal to X grams in 850 mLs. So, means and extremes. We got quick draw McGraw over there. Got our 100x equals how much? 4,250, which is 5 times 850, correct? Correct?
Yes.
Divide by 100 to get x by itself, divide by 100. So I have 42.5 grams of dextrose. Right? Okay, let's do the sodium chloride. So I have 0.45 grams in 100 mLs equals X grams in 850. So good so far, right? Good so far? 100x equal to 0.45 times 850, which is 332.5 divided by, goodness gracious. Okay, 382.5 x divided 100x divided by 100 to get rid of the hundreds, so x is by itself. Divide this side by 100. If you notice, if you're dividing by 100, I can just move that decimal place 2 places to the left. So 3.825 grams of sodium chloride. That is your answer. Make sure if you see a question for both, you answer for both. Very commonly last semester, I would put it like this: how much dextrose and how much sodium chloride, and I only get dextrose, or I only get sodium chloride as an answer. You need both for full credit. And make sure to show your work as much as possible. Okay? So if you put it together like this, 5 grams over 100 mLs equals X grams times 850 mLs, and then you put 100x equals 4250, and then you put 42.5 gram dextrose, that would be plenty. Okay? Just so I can follow your thought process in some sort of linear fashion. Okay? Any other questions? Yes?
When you're doing it in the thousands, like when it was 4,250, do not use commas.
You should use commas, but if I don't always use commas out of bad habit, but I will accept either or. Okay? So, but I know the book says always use commas, so I won't fault you if you do, but we don't use very big numbers all the time. Like you'll see the thousands here and there, but most of the time we're in the hundreds. And when we go to conversion of units, you might see 10,000 that I will ask you to do, and then you'll have to convert it to some sort of smaller number. So most of the time, you'll see on the homework that I use commas and stuff like that. But most of the time, you guys won't worry about it because your answers will be less than 1,000. So, but if you use them, great. If not, that's fine too. Just make sure you have you have leading zeros and no trailing zeros. And show your work. Okay? All right, you guys have a good one.